We are recording. I'm going to kick this right now to Dick to take it over.
Thanks, Jimmy, and thanks to all of you who have joined us. All of us in the education team have been experimenting with different formats and different ways of presenting things virtually and online. Today will be our first attempt at doing some technical training. The time slot that we have, of course, won't allow a lot of great detail, but if you feel that this has got some potential, please indicate so, and we can offer additional subjects and topics of technical training online during this time. Today, we're going to take a look at one of our 4 air conditioning trainers. This is our newest one, the EM2000HB1234. This is a air conditioning trainer that uses the 1234YF refrigerant. I'm introduce my remote hands. This is Kevin Bowden, the Console Lab president, and I get to tell him what to do today. It's kind of neat. So this trainer, I think, is going to reflect what OEMs are doing now. Just about everybody has gone to 1234YF. The price will come down as it did with 134A. I'll point out some of the features of our trainer. We're going to look at this a little more in detail, and I'm going to explain the internal operation of the internal heat exchanger and the H block, which are 2 things that often are misunderstood by students. But Kevin, point out the main components of the trainer, including the condenser, the evaporator, magnetic labels that we have for student identification of components. We have the compressor, receiver dryer, several clear sight glasses where the refrigerant change of state can be observed throughout the trainer. That's a really neat feature. It gives visual, learning of the change of state. High and low side pressure gauges, service fittings, hook up a recycling machine, inlet and outlet thermometers for the evaporator and the condenser, and the 2 items of concern today, the internal heat exchanger, or IHX, and the H block. The trainer is also equipped with variable speed cooling fans behind the condenser and the evaporator, which we can manipulate to create many different negative operational scenarios, plugged condenser, restricted, whatever. In addition, because we're using a non-automotive AC compressor, we are able to install restriction valves in both the high side and low side to create additional problems. Because of the EPA CAFE ratings and the EPA issuing energy credits to OEMs who increase the efficiencies of their vehicle systems, the IHX, or internal heat exchanger, is now being used on many vehicles and even some on the R134A systems. Other things that OEMs are using include variable displacement compressors, much less refrigerant and oil capacities, oil separators and compressors, modulating condensers, and many more. It's my personal opinion that because of R1234YF's low GWP number, most OEMs are currently using it and will continue to expand the use of this refrigerant in their vehicles. The majority of all new vehicles today are using 1234YF. Kevin is zoomed in on the IHX, let's say that again, IHX, and notice that it has 2 small lines and 2 large lines. The small lines are in the refrigerant high side system, and the large diameter lines are in the low side. This is true for all IHXs. At this point, I'm going to change views and open up a PowerPoint that I have to help us explain how these work. Bear with me. Okay. This is the internal heat exchanger. This is not one from a car, but it's a representative picture with the 2 large and 2 small lines. Commercial and industrial refrigeration has been using these for years. This is not a new technology, but because of the energy credits, now OEMs are starting to use it because they get EPA credits for system efficiencies. Both high side and low side are connected to it, but they do not internally mix. This is a picture of a Chrysler product. Chrysler was the first one to adopt IHXs, and that's primarily because they needed more energy credits than most. Their corporate fuel economy wasn't great, so they were the first ones to adopt it. GM now has some, and I believe Ford also is using them. This is a graphic that we've designed to help you understand how an IHX works. So we have one smaller high side line that comes from the outlet of the condenser where warm liquid refrigerant enters one end of the IHX. The warmer refrigerant flows through the IHX, giving up some of its heat to the IHX and exits, then flowing to the H block metering device. The one larger low side line coming from the evaporator outlet connects to the IHX, where the refrigerant vapor is heated by the heat taken from the high side line. They are not internally connected, but only transfer of heat occurs. This heat ensures that any liquid droplets are boiled off so that we don't slug the compressor. It leaves the IHX on the large line and heads off into the H block. Any questions?
This is Russ.
Yes.
I see on the bottom of your slide the the toolbar for Teams. Do you see that?
You can get rid of that if you want by just
No, I think
clicking
it's
outside.
yours. I think it's yours though, because it also shows in the corner me speaking.
Yeah.
And
Click that. There you go. Click
How's
that.
that?
That's
there
perfect.
you go. Much better.
My mistake. I'm still getting used to this technology.
Oh, this is great. Thank you.
Okay, so this is a graphic cutaway, cold gas from the evaporator to the compressor in this case, and of course the hot liquid from the condenser to the H block valve. This one has the high side flowing on the inside and the low side on the outside. It can be reversed. It can be reverse flow depending on the OEM preference. They're usually insulated with some type of insulation. It could be a braid or rubber. It's not just bare metal to the outside. This is a picture of a 2014 Cadillac with the internal heat exchanger. You see that the red arrows are pointing to the high side inlet and outlet, and the blue arrows are pointing to the low side inlet and outlet. Well, before we go on, does anybody have any questions on the IHX? Has anybody seen one on a vehicle and wondered what it was? It's going to be a fairly common thing. In my opinion, it's relatively trouble-free. The only thing that might happen to it, of course, is the source for leaks, physical damage from somebody wrenching on the engine and damaging one of the tubes or whatever, but it should be a fairly maintenance-free item, not giving us much problem.
Joe Hart was wondering if all 1234YF systems will be built on H block design, or are there any other orifice tube systems?
The orifice tube is going away rapidly, and everyone is replacing it with the H block. I'm going to discuss the H block here in a moment, but it's my opinion that the orifice tube, which was good and was designed to replace the problem with the capillary tube and sensing bulb on the TXV, It has some problems with a screen in there, of course, that everyone called Black Death when you had a compressor failure. And then other reasons for the accurate flow of refrigerant as a metering device. But it's my opinion and others that the orifice tube is being replaced pretty much with the H block. I don't know, to answer Joe's question, I don't personally know of a 1234 system that uses an orifice tube. If there is one, I'm unaware of it. Rick, do you have any idea if that is true?
And Dan from chat said, just to recap, the purpose of the IHX is to ensure all liquid is turned to gas before entering the compressor.
It is an efficiency tool to do exactly that. We're using the heat from the high side liquid refrigerant to heat up the remaining droplets of vapor in the outlet of the evaporator to make sure that there is nothing but vapor, warm vapor, coming out of the IHX and into the compressor. It is an energy saving device.
And Richard Smith wants to know, is any of it being used on heavy trucker equipment?
I can't answer that, Richard, because I don't know. Maybe Jeff could chip in if he knows anything about it. I'm sure it will, because it makes sense, but I don't know specifically if that's true.
And I would ask Marshall Link to chip in on that answer. I am unsure either. I haven't seen any.
Marshall, are you there?
Let's move on.
Yeah, I'm here. I'm also unsure at the moment. I can look into that and get back to you guys.
Okay.
Richard, you stumped the band.
No problem. Okay. This H block is a mystery to some people, and it really isn't to those that have had, extensive experiences with the air conditioning. But as I said, it's replacing the orifice tube, and we have a trainer with the H block. We have a trainer with the TXV, but this one is the H block, and I've cut it away. I'll show you what's going on here. It is a metering device. It is designed to meter the flow of refrigerant into the evaporator. And so we have the same diaphragm that was on all TXVs is still there. There is a temperature sensing element inside, and you can imagine that those two large lines then will be the evaporator, and we can sense the temperature of the refrigerant leaving the evaporator. We have a push rod, and then the actual control of the flow of refrigerant through the H block is a ball valve, and it modulates the flow of refrigerant into the evaporator based on its outlet temperature. So from the condenser, we have liquid flowing into the H block, usually at the bottom. Now it comes from the receiver dryer, or if the car has an IHX, it would come from there. It is a liquid refrigerant under high pressure and high temperature. After the valve modulates that flow, it changes state to a low pressure liquid with a little bit of vapor in it, maybe depending on conditions, and it enters the evaporator. So there's your metering device. That's where the orifice tube would be if it was an orifice tube system. It comes out of the evaporator as a vapor, and it's immediately sensed the temperature by the temperature sensing unit, which then controls the flow of refrigerant by opening and closing that ball valve or modulating it. It leaves the H block and goes to the compressor inlet or the IHX if it has one installed, and it's all vapor. Now, these animations that you see, I'm going to share them with you in a PowerPoint. The PowerPoint is available on our resources, or soon will be. It has 150 plus slides in it. Now that's a lot, but it covers the whole parameter of air conditioning, 1234YF systems, different refrigerants, all the new compressors, hybrid electric vehicles, all of the new SAE J standards are there, service tips, diagnosis and procedure. It's a very long PowerPoint, and you can pick and choose because I'm giving you an editable version. So you can use it, take slides out, add slides, whatever you wish. That will be available on our resources tab. Any questions on H blocks? We have actually a product that's a cutaway H block. I'll get Kevin a little later on to show you one, but it's just an H block that's cut in half so you can see these elements inside. It is the metering device of choice today. I thought I'd throw in a couple of diagnostic strategies that aren't typically used by a lot of vehicle technicians. This one involves measuring the temperature across the evaporator and the condenser inlet and outlets. Now, in order to do that, you have to gain access to those 4 points, of course, and then you want to make sure that you accurately measure that temperature. And I'll give you some tips on how I suggest that you do that. If you have an evaporator, you want very little temperature change between the inlet and outlet, 0 or plus or minus 5 degrees. That's normal. If it's more than that, it's probably overcharged. On the condenser, you want about a 20 to 50 degree difference between the inlet and outlet. More, it's undercharged or is restricted, either refrigerant restricted or airflow restriction. Less is overcharged. This is a silver bullet. It's a ballpark, but it's a quick and easy way of determining the state of charge and efficiency of your system. In order to do that, I suggest not using an infrared thermometer. And the reason for that is if you shine an infrared thermometer on the wall, you'll usually see a target, red dots of a target that's usually 4 to 6 inches in diameter and does not give you an accurate indication of one particular point, which is what you want to measure when you're doing this test. So this is the immersion probe that comes with many DVOMs. I suggest not using that. It's not designed for a contact surface. This is a narrow, real skinny contact probe. I suggest not using either one of those. This is the one that I use, and it's merely a contact temperature probe, but it has about a 1/2 inch diameter contact surface, which will give you a very accurate probe temperature of that spot you're touching. It wants to be clean, no grease or crud buildup on it, and you'll get an accurate reading. Many DVOMs don't come with a K-type receptacle, but you can buy an adapter, and there's a chart that converts your voltage to a temperature. They're very inexpensive. Any questions?
In the chat here is from Josh Finley, says, what about a thermal camera?
You know, a FLIR camera, I don't have any experience with them. I know Jeff Curtis has some. I'm not sure they can focus in on a particular spot to give you a temperature. They can show you, you know, a thermal image of hot and cold, but I don't know if you could actually measure a real close spot. If you can, then absolutely. Absolutely.
Yeah, Dick's correct. It gives an overall view, though, that's really quite stunning when the first time you see it, especially if it's going through an orifice or something like that. The temperature change is just so visible. It's a great way to teach if you have one.
Yeah, we've seen some amazing things. Exhaust systems, you know, heat change, even you can detect a dead cylinder almost with a change. It's pretty impressive. I don't have any experience at all with them because I can't afford one, but they are nice. There's a relatively new to vehicle mechanic or vehicle technicians that in using diagnosis, most of us are used to hooking up our gauge set, throwing a thermometer in the evaporator outlet inside the car, and based on our experience and our knowledge, we try to make diagnosis that way. The commercial and industrial HVAC technicians use superheat and subcooling, and they do that every day. And Rick and I have been talking about this for a while. We believe, and there are some auto technicians, truck technicians that use this, but we would like to at least present it to you. And there's not going to be a time today to cover all of the details of how to do it. It's really not that terribly complicated, but I will offer you on the resources an instructional document I put together on what checking subcooling and superheat really is. There's a video that we're going to show you. There is the first page of the definition document I put together that explains saturation, subcooling, and superheat. It is a very accurate way of determining the efficiency of the evaporator, the condenser, and your whole system. And there is the video that we're suggesting you watch. I watched it, Rick watched it. It's a very good introductory video that describes those three terms: saturation, subcooling, and superheat. It's a non-automotive application, but refrigeration is refrigeration, and the guy does a real good job of that. That's also going to be on the resources tab for you to look at. Does anybody use subcooling to superheat?
Oops, sorry, go ahead.
Does anybody use this technique when they diagnose their air conditioning system? I think it would benefit all of us, if you took a look at that document and understood the accuracy of that. Rick, you want to make a comment on that?
Oh, it's something, it really can give you some more information about what your levels of refrigerant are like in your heat exchangers. Like Dick said, it's, if you're working in commercial refrigeration, you're using this all the time. Same with anybody that's working on refrigerated trailers, those as well. They've been taught this as well, just for diagnostic purposes. So superheat is just the additional heat that we add after the change of state in an evaporator, and subcooling is the removal of more heat after we've changed back to a liquid. And really, it's one of the operating principles of the IHX Dick was talking about as well. So good info.
Thanks, Rick. Again, that is available in the resources, and part of that is a pressure temperature chart for 1234YF that you will have available to you. I know you've seen PT charts before, but you need a PT chart for either 134A or 1234YF or any refrigerant that you're working on, so you can convert the pressure that you're recording on your gauge to a temperature. And that's what the PT chart does. And then Rick has put this together that I really like. This is a simplified drawing that your students can actually do themselves, and it helps them understand the refrigeration cycle. Rick, you want to comment on that?
So the whole idea behind this was to have the students have a device that they could create quickly when we're working with air conditioning in class or in the lab. It's simply drawing a circle and putting all of the components around the circle, and thinking about placing. So condenser typically went on the top of it because it was high pressure. Evaporator went at the bottom because it was low pressure. And then we also know that we have to divide between vapor and liquid. So by putting liquid on the right-hand side and vapor on the left-hand side, we can now have the compressor and metering device shown as well. And we know that, we have liquid going through our metering device. We change state in the evaporator from liquid to vapor. We must have vapor going through the compressor. Coming out of there, we increase the pressure of the vapor, goes to the condenser, changes back to a liquid, and comes around. And then the arrows just help us also with heat. Blue arrows for the low and cold, and red arrows for the high and hot. Just a simple device you can pass on to them, and can help them through even exams.
Thanks, Rick. I have seen so many textbooks do what I would call an overcomplicated job of explaining the refrigeration cycle. This is the simplest one that makes sense to me that I've ever seen, and I'll give Rick full credit for doing that. This chart is also on the resources tab that you can download yourself. In this PowerPoint that I'm sharing with you are all four of our trainers, the TXV, the H block with 1234, and the orifice tube. And each one will have this animation that shows the flow of refrigerant through each of the trainers so that you can help your students understand the refrigeration cycle and how it flows. That is also available for you. In addition to that, there are over 20 Halderman animations that I've received his permission to share with you. All of the different types of compressors, hybrids, EVs, variable displacement, swash plate, wobble plate are all there, and each one is explained in that PowerPoint that you can, again, download and edit as you see fit. So there's quite a few Halderman animations in there, and if some of you have been on his website and used those animations, there's over 2,000 of them in there. They're very powerful teaching aids. And I know he's just changed from a free website to a subscription website, but there's still very powerful things in there.
Dick, if I may add two
Currently free
things.
right now, currently free.
Yeah.
Dick, if I may add to that, it's currently free, like Jimmy said. The other is that Tom Birch is the author of most of Jim's animations. Tom Birch in California, one of our NACAT California members.
I know Tom quite well, and he's in his 80s and he still loves doing this. I mean, even today he's working for Jim on putting new animations together. Okay.
3 minutes.
We're pretty much done with what I wanted to accomplish today. If you feel that it was valuable, we can do other portions of the refrigeration cycle, diagnosis, testing on whatever system you'd like. Right now, do you have any questions or opinions you'd like to share with us?
Can we kick it back to Kevin and see the change in phase?
Just a second, we will. Just want to make sure that you know that all of this information is available on our website. You go to the website and click on resources. Let me stop here and unshare my screen and let Kevin go back to a wrap up. Kevin, you're on.
All right, there you go.
Show that H block cutaway that we can just make sure they see that. There it is. You see basically what I was explaining during the PowerPoint.
Dick, Joe Hart said, I would like to see 1234YF diagnosis. Does it work similar to 134?
The nice thing about 1234YF is its pressure and temperature performance characteristics are almost exactly to 134A. The only time they're a little different is on the high end of the spectrum. You could, and I don't want to say that, well, you can use, with adapters, you could use a 134A gauge set on 1234YF. I wouldn't suggest you do that because of the possibility of cross-contamination. But to answer Joe's question, the performance characteristics are almost identical.
One of the other things in the resources will be a PT chart that we created for 1234YF as well.
Okay. With that, I'd like to thank my remote hands, Kevin, for his work, and thank you for your attention. If there's any other comments or questions, I'll stick around afterwards for the tailgate. And I hope you got something out of this. Thank you for your time.
Thank you, Dick. I'm going to stop the recording now.